Today we shall discuss SEMEDX, which stands for Scanning Electron Microscope Energy Dispersive System. The method involves use of electron microscope, which has many advantages over the other methods because we can photograph the GSR particle up to a magnification of about 2 lakhs in case of scanning electron microscope, which has not only high magnification but it also have greater depth of focus and most useful for the analysis of GSR particles. The system of analysis utilizes electron microscope in the following manner. Electrons from an electron gun are focused on the GSR particles. These GSI particles, some of them become excited after falling of the electrons, and these emit characteristic X-rays. These characteristic X-rays are analyzed by X-ray detectors. Their detection results in the identification of element present in the sample. All this looks very good, but there is a great disadvantage with the electron microscope, and the disadvantage is that it requires preparation of the sample. The sample needs to be coated with a metallic coating so that the electrons can be reflected properly. If they are not coated, the electron will simply get absorbed and there will be no result. Hence, it is difficult to maintain such a costly apparatus. It requires a lot of space and also it requires huge maintenance cost. That is why it is not normally used by many laboratories in India. But this is one of the best methods if we can have the gold coating of the GSR particles.
Dear students, after studying this module, you shall be able to know about the basic concept of gunshot residue and its importance. Along with it, you'll come to know about GSR examination collected from shooter's hand, and you'll learn about the principles of EDX and electron microscopy. Let us start with Introduction to Gunshot Residues. Chemical particles, which are frequently referred to as firearm discharge residues, are also represented as gunshot residues. Gunshot residue is produced due to burning of powder, rubbing of bullet with barrel parts, and explosion of priming compounds. GSR particles may be found as inorganic elements, organic compounds, or gases. GSR particular may be found on the target, and when the target is a human being, they may exit on the body of the victim and on his clothes depending on the range of firing and other factors. GSR particles may be found on the hands of the shooter, inside the body of the victim, as well as at some distance from the place of firing, depending on firing range. In cases of suicide, GSR particles can be found on the body of the shooter as well as on his clothes. GSR particles may be found in the barrel and chamber of the weapon as well as on the outside of the barrel. These GSR particles may be found in the air. Presence of GSR particles has even been reported in the excreta of the shooter. Now, in India, the new primer composition being used is lead stiphanate in 32.42%, antimony sulfide in 13.17%, barium nitrate 27 to 37%, PTN 4 to 6%, tetracene 3 to 5%, and last aluminium in 6 to 8%. Thus, the elements present in the GSR would be lead, antimony, barium, and aluminium. In addition to above elements produced from the primer, we may have contribution from other sources. Some particles of plain lead which has vaporized from the base of the bullet, copper and zinc particles from the inside surface of the cartridge case. Now let us have a look on electron microscopy in GSR analysis. Let me give you a brief introduction to electron microscope. Electron microscopes are used for getting enlarged images of small objects or a small portion of large object using electron beams. The lenses used in these microscopes are electrostatic or electromagnetic lenses. Since glass lenses have no effect on the electron beam, they are not used. Now, electron microscope has high magnification. In certain cases, the magnification can be achieved up to 2 into 10 to the power 5x. It is extensively used in the field of biology and other material sciences. In scanning electron microscope, three-dimensional external shape of an object with greater depth of field can be obtained. Unlike the light microscope, the electron microscope uses electrons as the former one uses photons for visualization. Compared to optical microscope, electron microscopes are very recent invention. The image is made visible by use of fluorescent screen which has the coating of lead sulfide. Now the basic design of an electromagnetic lens is a solenoid. Solenoid is basically a coil of wire around the outside of a tube, now through which electric current is passed, thereby inducing an electromagnetic field, and the beam is controlled by adjusting current as electrons are very sensitive to magnetic field. Now there are two types of electron microscope. Number one is STEM, which is known as transmission electron microscope, and the second one is SEM. Its full form is scanning electron microscope. In the TEM, an electron beam is passed through an extremely thin section of specimen and a 2D cross section of specimen is obtained. SEM, in contrast, visualizes the surface or structure of the specimen, providing a 3D impression. Now, let me shed light on utility of electron microscope in forensic science. A wide variety of sample encountered in crime investigation can be examined by scanning electron microscope, which include hair, fibers including paper fibers, GSR, which is subject in hand, that is also known as gunshot residues, biological specimens, metallic fragments, especially broken parts of bullets, dust, powders including phenolphthalein powder used on currency notes while laying a trap to catch a corrupt official demanding and accepting bribe. However, electron microscope has certain disadvantages like they're expensive and their maintenance costs are much high. Then the system requires a large and dedicated space for installation. Sample preparation is often much more elaborative since it is often necessary to coat this specimen with a thin layer of metal such as gold to reflect the electrons. Then the significant disadvantage is that the sample must be dried completely and living specimen cannot be observed. Now, it is not possible to observe different colors in electron microscope. Considerable experience and training is required for experts to identify artifacts. Now, Let me tell you something about principle used in electron microscopy. According to de Broglie equation, which expresses relation between the velocity with which an electron is moving and its associated wavelength in the following manner, that is lambda is equal to h by mv. Now kinetic energy of an electron can be calculated in two different manners: from the velocity with which it is moving, from voltage, which is denoted by v, through which it has been accelerated for attaining velocity, which is denoted by small v, and kinetic energy of an electron moving and having a mass m is Ke is equal to half mv square. Ke of an electron with charge E and accelerated through a voltage V is K is equal to EV. From equation 2 and 3 you can see that EV is equal to half mv square. Multiplying both sides of the equation by m gives MEV is equal to half m square v square, or it can also be written as 2 MeV is equal to m square into v square. After taking square root, the formula goes under root 2 MeV is equal to mv. Now substitute the value of mv in the equation 1 and you'll get lambda is equal to. Now substituting the value of Planck's constant h, mass of electron m and its charge e, will get lambda is equal to 12.2 into 10 to the power minus 8 by under root v. Thus, it is clear that exercise in accelerating voltage will result in decrease of wavelength of an electron, thereby increasing its magnification resolution and depth of focus. Now, let us talk about instrumentation. The important or main parts of the electron microscope. Number 1, electron gun. Now electron gun, it serves as electron source and supplies electron. Number 2 is condenser lens. It controls the illumination of the specimen by the beam of electron and may be a magnetic field. To provide intense illumination, double condenser or two lenses may be used. Then comes objective lens, an objective lens inserted within the aperture for limiting it. Another part is projection lens. This is the lens which has been replaced by an eyepiece in a light microscope. Then is fluorescent screen. The fluorescent screen shows the final image with the direct impact of electron beam on it. The material used for coating the screen is lead sulfide. Since electrons are unable to penetrate through matter, their path needs to remain evacuated. Let us have a look on GSR from shooter's hand and its examination. One application of scanning electron microscopy has been to determine whether a suspect has recently fired a gun. In this regard, an attempt is made to remove gunshot particles that remain on a shooter's hand by lifting them off with a piece of adhesive tape. The tape is then examined under the SEM for the presence of particles that may have originated from the bullet primer. These particles can be characterized by their size, shape, and elemental composition. As shown in the figure, when the sample of gunshot residue is exposed to a beam of electrons from scanning electron microscope, X-rays are emitted. These X-rays are passed into a detector where they are converted into electrical signals. These signals are sorted and displayed according to their energies of the emitted X-rays. Through the use this technique, the elements lead, antimony, and barium, frequently found in most primers, can be rapidly detected and identified. Now, let me tell you something about advantages of SEM analysis. Analysis of GSR particle by SEM is beyond doubt the best method because of several reasons. Number 1, it does not destroy the sample as it is non-destructive. Number 2, the result of analysis of GSR particles can be verified if required at any time. Number 3, it can provide documentary proof of analysis. Number 4, the material required for analysis is quite small. Number 5, and the last one, SEM has a very high magnification, better resolving power, and greater depth of focus. Then comes energy dispersive X-ray fluorescence spectrometry, also known as EDXRF. Now, the technique finds applications in the analysis of metals. The following table represents the limit of detection of different metals by EDXRF. This table is divided into two sections, one containing element and the other containing limit of detection. The EDXRF technique is rapid, non-destructive, requiring only sample preparation by microwave digestion or pulverization of sample, as it does not require drastic reagent or additional waste stream. This is a safe technique. The entire method is electronic data based and very fast. Let us have a look on SEMEDX method. Scanning electron microscope with energy dispersive X-ray analysis. Now, primary electrons having higher energy are made to fall on the particles under analysis. The X-rays emitted are then detected by X-ray detector. This X-ray detector measures the energy in each photon of X-ray radiation, and these quanta of energy can be stored electronically. A histogram of number of quanta versus the energy can be drawn. From this histogram, elemental analysis of particles under examination can be determined. Dear students, now let me summarize this chapter for you. In this chapter, I have told you about the GSR, and we have come to know that GSR is produced due to burning of powder, rubbing of bullet with barrel parts, and explosion of priming compounds. Along with it, I have also discussed that GSR particular may be found on the target, and when the target is a human being, they may exist on the body of the victim and on his clothes, depending on the range of firing and other factors. Along with it, in this chapter, we have discussed that gunshot residue particles may be found in the barrel and as well as in chamber of the weapon, along with the outside of the barrel. And we have come to know that the most successful technique to data for the analysis of gunshot residue particles is the scanning electron microscope with an energy dispersive X-ray analyzer. In this chapter, we have learned that a beam of electrons visualizes the object under observation rather than visible light as in conventional optical microscope, as the beam of electrons is focused by a series of magnets rather than glass lenses. The control is infinitely finer over here. And because of the fact that electrons behave like much smaller wavelength, It has resulted in much more magnification, higher resolution, and greater depth of focus. Now, magnification in a scanning electron microscope can be controlled over a range of up to 6 orders of magnitude, from about 10 to 2 into 10 to the power 5 times. In addition, on striking the sample, the electrons give up some of their energy to the element present in the gunshot residue. Now, this energy produces X rays, the wavelength of which is characteristic to the element present. Along with it, we have come to know that one of the biggest advantages to the forensic scientist is that gunshot residue particle analysis is a non destructive method in nature, and the sample can be preserved for court evidences as well. Whereas most of the techniques used for this type of analysis are destructive in nature. So, we have a benefit in this case. Another significant advantage of scanning electron microscope with energy dispersive X-ray analysis is that it provides a documentary proof of its findings, which can be later produced in the court as evidence and can be preserved for a very long time.